Okay, first thing I want to look at is, let's look at a number 18. Now, I'm going over the answers to about 3 of these. If you miss these once you turn this in, that's the situation. Look at 18. I just want to make sure we still know how to factor. I don't know if you do bust them up, AC hard, slide divide, but you just need to make sure you have the same answers and your way came up with this. I do bust them up. 4 times negative 15, it multiplies to give you a negative 60, add to give you 4. Thank you, buddy. Add to give you 4. Well, that's positive 10 and negative 6. I bust that term into 2 of them. Group it. Factor by grouping. And I get 2x minus 3 and 2x plus 5. So my answers are 3 halves and negative 5 halves. I need to factor it because it's set equal to what? 0. So I got to factor it and solve it. Yes, Jack?
I have a question about 21. Is it supposed to have a...
Yes, we're about to do 21. We're going to do 21 in just a second. That's the one I really want us to pay attention to. So everybody good with 18? That kind of all this is going to be on that test Friday. All right, let's go back and look at 13 quickly. This is a very simple one. I don't want you to miss a simple one. X squared equals 9x. I need to get that in standard form. Set equal to 0. That's just GCF. You take an x out, it's not difference of squares because that x doesn't have a square, is it? If it was just x squared minus 9, that would be difference of squares. Does everybody agree? So I took the x out. Now, I set that equal to 0, and I set that equal to 0. So I got 0 and 9. If I'm going over this, you got one just like each of these. If you're having trouble with factoring or whatever, come see me at 0 period. I'm not going to beg you, but I'm telling you, you need to come to 0 period. Now, this is where we didn't see one like this in chapter 1, so let's talk about this one. Remember, in a radical equation, for the most part, radicals are easy. But this one is a long one. But for most part, you want to get the radical by itself. I did. I moved the 2 over and became x minus 2. Well, to get rid of that radical, I squared both sides. Squared both sides. So I have 2x minus 1, and I squared that. That's x squared minus 4x plus 4. Now, it's went from a radical to a quadratic. Now, when I transform like that, do you normally need to check your answers? Yes, this is where you would check your answers in a minute. So I got it set equal to 0, and I got this pretty easy trinomial to factor. Well, that's easy. It's got to multiply to give you 5, add to give you negative 6, negative 5 and negative 1. I solve it, and I get 5 and 1. Well, then I got to plug it back in to see which one works. So I plug 5 in to the original. What's 2 times 5? 10 minus 1 is? Square root of 9 is? 3 plus 2 is? Did it equal 5? So that's one of my answers. Try 1. 2 times. Now, I plug 1 in here. It's got to equal 1, don't it? So watch this. 2 times 1 is? 2 minus 1 is? Square root of 1 is? 1 plus 2 is? That didn't equal 1, did it? Okay, if you need to take a picture of that, you can. You got one like that on test on Friday. Correct yours. If you already turn your math workshop into that first drawer and want to get it out and change it, you can, okay? Does that one make sense? All right, let's look at 3 trig just to make sure we're good. Cotangent negative pi. Well, negative pi is one of the major points, isn't it? So I don't have to do all the reference notes. I just put my ordered pair down. Remember, cotangent is x divided by y. Well, negative 1 divided by 0. 0 is under. It's what? Undefined. Number 8. Cosecant is negative 7 pi over 6. Okay, first off, how many times does 6 go into 7? 1. So it's 1 and 1/6, isn't it? So I go here. That's 1. I need 1/6 more. What quadrant? 3. So that means I went 1, 2, 3. But since it's negative, do I go in that normal direction? No. So I'm going backwards. So it's 1, 2, 3. You still got to know how many quadrants you go in. Normal, I would have went quadrant 3, but now I'm going backwards, so I'm in quad 2. Does that make sense?
So that's supposed to be positive?
I got positive 2.
Okay, yes, I probably made a mistake, so let me just check it. So that's quad 2, pi over 6. Yes, that's supposed to be positive 2. Yes, that's quad 2. Your y value is positive. Thank you for catching that. Number 11. I'm going to change that to mixed number. It's 2 and 1/6. So 2 whole means I went around the unit circle. I'm back to my starting point. I need 1/6 more, so I'm in quad what? 1. Pi over 6. Square root of 3 over 2, comma 1/2. Tangent is y divided by x. I'm going to give you a practice Tricky Tuesday tomorrow. I know it's not Tricky Tuesday, but I want you to get the feel of 4 minutes tomorrow on this. It's not going in the grade book, but you're going to get a feel for this. We're going to see where you're at the moment. And then y divided by x. I get 1 over this. You can't submit it like this. So I rationalize the denominator. Are we good? Okay. Put that away. If you're done week 5 and you really want to go on turn it in, put it in the basket.
Do we need to have the...
No, just the front of it. Because those after we get through this week, I'm going to start doing ACT. I'm going to run y'all an ACT test off, and that's what's going to be our math workshop. I just got to get through this week. All right. So let's talk about your test. I'm going to go through this rather quickly because we got several things we need to do. All right. For the most part, number 1 and 2, you did great. Those were 4 points apiece. The definitions were 2 points apiece. 3 and 4, y'all did good. If there was any mistakes with simple algebra, just be careful on that. 5, 6, and 7, you did pretty good on that. Those are 4 points apiece. One thing I ask of you guys, I know that you just want to do it quick, but if you see it's a parentheses and it's supposed to be a bracket, some of y'all just try to write over it, completely erase and put what you need there, okay? Because if I have to keep guessing, I'm just going to mark it wrong, what I think you wrote there. Does that make sense? Just take the time to erase, please, and correct it, not try to write over it. Number 8, you did fine. That is incorrect because it should be 5, parentheses 5 to infinity. 9, 10, 11, y'all did fine. Those were 4 points apiece. 2 points for correct. 2 points for correct if it's even, odd, neither. 2 points that you had to work to back it up, okay? So if you made a simple mistake, if you worked it out and plugged in negative x, you had to work it out correctly for that. 12, 13, 14, those blanks were 2 points each. Y'all did good on that. On the back, number 15, each of those blanks were 2 points. Y'all did really good on 15. 16, you did great on that one. It was 2 points, 1 point for the first question, 1 point for the numerical reason. Number 17, when I have to, how many parts in that question? 3. If I couldn't read your problem and get all 3 parts out of that, then I took a point off or something. Each one of those is a point. The first question, point. Some of y'all did the first question and didn't tell me if it could be classified as such, or I couldn't get that out of your question. So just be very careful and mindful of making sure you answer the question complete. Yes?
What do you mean by functionally classified?
Okay, so first thing I would have done on number 17, it says, if f of negative x equals fx, what type of function can be classified? I would put, this type of function is an even function. Can this function be classified? Yes, this function can be classified as even, and then I would have gave my proof. So it would have been those 3 parts to it, okay? Just make sure you answer it complete. Alright, turn them over and let one person collect them in your group and bring that to me. Turn your grade face down and one person bring them to me now. Okay. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. What you found on your desk when you came in here was a note taker for average rate of change. Just put that somewhere in this unit. I like it better than what was ran off. Thank you. And the other thing was a homework sheet. It's not numbered, but just know most of your homework's going to come off that homework sheet. So when you see homework sheet, that's what I'm talking about. Does that make sense? Is everybody clear on that?
Where do you want to put all these?
Wherever you can find it at in that unit is fine.
And then you say about average rate of change.
Just put that note taker somewhere as well in your notes that you can find it easily. And then I want you to get that, we got to go over your homework. All right, get out your homework that you did in class. For the most part, y'all completed it. It was on if it's continuous or discontinuous.
Okay, put it on a sheet of paper.
Yes, it's fine. All right. So our learning target on Friday was I can determine if a point is continuous at a given point. I can determine if the function is continuous at a given point. That means it exists at that point. So let's look at these three examples. I have this example function equals square root of x plus 5 at x equals 8. First thing you do is try to plug it what? In. 8 plus 5 is what? Is square root 13 okay? So would it be yes at this point? Then I have here x over x minus 2 at x equals 2. I take 2 and I plug in that denominator. What's 2 minus 2?
0.
Can 0 be in the denominator? So it's discontinuous. Once I determine if it's discontinuous, I got to think what type of discontinuity. We had infinite, jump, and removable. Jump is always related to which one? Piecewise. So it's either infinite or removable. Removable only occurs when you can cancel out the factors. Infinite is when you can't do anything. But what does removable mean? There's a what in the graph? Whole. Infinite means there's a what present? Asymptote. So right here, can I cancel anything out? So what would this be an example of? Infinite. I need all eyes up here, please. Number 3. I can look at that and tell it's a what? Is it continuous? No. What type is this? Jump. Okay, on this one, x equals 1, x equals 4. I have this. I went ahead and factored it, so we didn't have to take time for that. X equals 1. Well, I can look at that. 1 minus 1 is what? There's going to be 0 in the denominator. Can I cancel out that x, any x minus 1? So removable or infinite? Infinite. X equals 4. Can I cancel that out?
Yes.
Infinite or removable? Do you remember that from Friday? Okay? Emma, will you keep Gracie's and give that to her tomorrow, please? Thank you. All right, so I went ahead and worked the homework out, so this will be quick. Number 1, I plug it in. Yes, it is continuous. You get an answer of square root of 21. Check your answers, because this will be on your quiz on Thursday as well. Number 2, we're looking at x equals negative 6. Well, I plug that in, I get no here. Well, then I factor it. I can see I can cancel those out. Since if I set that equal to 0, won't that be related to the x plus 6? So that's why if I can remove it, it's removable. Does that make sense? At x equals 6, if I take 6 and plug it in, I didn't get 0 in the denominator. So that's continuous. That's continuous. And my value is f of 6 equals 0. 0 on top is 0. Number 3, I'm wondering if it is continuous at x equals 8. Take 8 in. I plug it in. 8 plus 5 is 13. I'm good with that. That means it's continuous. Number 4, I want to determine if it's continuous at x equals -5 and x equals 5. Well, I do some factoring. I plug -5 into the original. That gives me 0. So I know it's not continuous. That's why I put no there. Okay? I plug 5 in. I get 5 plus 5 is 10. Okay? That's continuous. 0 divided by 10 is 0. That's good. Now I got to factor it to see what type this is. Well, I factor it. If I set that equal to 0, that would be related to that parentheses there. I can cancel. I can remove it. That's why it's removable. Number 5, I don't have to do any work. It's piecewise. That is not continuous, and that's a jump. Number 6, x equals 1. I take 1, plug it in. 1 minus 1 is 0, so that's not continuous. I can't do any canceling, so it's infinite. Are there any questions so far? Number 7, I want to determine that x equals 1 and x equals 4. Okay? I factor it, so I see what's going on. Well, x equals 1, that's related to this parentheses. I can't do any canceling, so that's infinite. X equals 4 is related to this parentheses. Can I cancel those out? That is removable. 8 is a piecewise. No, it's a jump automatically. Number 9, I take -2. I plug it in. 2 plus -2 is 0. That's a no. You cannot mark that out. That's not exactly the same. That is infinite.
Which one is that?
Number 9. Now, at x equals 2 it is, because 2 plus 2 is 4. After I plug 2 in, I get 0 over 4. 0 divided by 4 is 0. So it is continuous at that point. It's not at x equals -2. And then finally, number 10, I take -4. I plug in and I get 0 in the denominator. So it's no. I cannot cancel it out, so it is infinite. What does infinite mean? There's a what at that moment? Asymptote. Yep. Are there any questions on your homework? Does it make more sense today? I need a hand signal how you feel on the homework. Okay, if you're having trouble with that, come see me, okay? Alright. Now, our learning target today, guys, is I can determine the AROC of a function. AROC. AROC stands for average rate of change, okay? So let's look at this chart for a minute. You've learned up to this point rate of change. That's otherwise known as slope. Okay? That is slope. But we're going from slope to average rate of change. And I want to compare the two so you get a good understanding of what those two really are. Rate of change is known as the slope. And you know the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Slope is only for what type of functions? Linear, because they are a constant line. You see a straight line. They have a constant rise over run. Example, you know how to find the slope of something. Now, how does this compare to average rate of change? Alright, it's known, that's the abbreviation. Okay, that looks very similar to that, don't it? Okay, you see the x sub 2 minus x sub 1 on bottom. This is technically the same thing because isn't f of x y? So I see y sub 2 is going to be f of x sub 2 minus y sub 1 is f of x sub 1. So technically it's the same thing, isn't it? Okay? It is used for other functions such as polynomial, radical, rational. So this is for everything else. This is for just what functions? Linear. And you say, okay, so why do you use that for the other function? The other functions do different shapes. Don't they increase, decrease at different things? So you cannot find the perfect slope because you just have to take a part of the graph and find the slope of part of a graph at one time. It's basically over, okay, I'm studying this part of the graph. I want to know what's the rate of change from x equals 1 to x equals 3. That's what you're dealing with average rate of change. It's over a specific interval. Okay? For example, let's say I have this function, negative x to the third plus 3x. What type is that? That's a cubic, isn't it? That's not a linear, is it? So I want to know what's going on with this cubic function from negative 2 to negative 1 bracket. That means I want to know what's going on, the rate of change from negative 2 to negative 1. So in order to find that rate of change, you would have to find the y values first. So that's why I got f of negative 2, found that y value to be 2. F of 1, negative 2. So I found my y values. Now, these are my x values. That's telling you the domain you'll want to find it over. So what's x sub 2? Negative 1. I'm still following this formula. Minus, what's x sub 1? Negative 2. And then you go right above there. Okay, since negative 1 comes first, I would find my, that's supposed to be a negative right there. I would put this value right above it for my y value minus the y value of my x right there. And just work it out like normal slope. Does that make sense? And that's what we're doing today, okay? So use average rate of change for other functions that are not constant. Linear functions are constant. All right, so let's look at this. It says, Mr. Bishop and his family leave on a car trip Saturday morning at 5 a.m. and arrives at the destination at 11 a.m. When he began the trip, the car's odometer read 44,520 kilometers, and when he arrived, it read 45,000 kilometers. What was the average speed for his trip?
Kilometers.
Huh? Kilometers, yep. Alright, so you got two things working in here, guys. You have time and mileage, don't you? You're going to say, Mr. Chester, well, what is your X? What is your Y? Okay. Time, can you control time? So is that your independent or dependent variable? Independent. What is independent? Your X or Y? X. So your time would be your X, okay? So what I would do here, okay, what time did I get there? So that would be my X sub 2 minus, what time did I leave? 5. You said, Mr. Chester, I just knew that was 6 hours and put 6 hours down there. Well, that's fine. But I'm going to do 11 minus 5.
You have to be careful though, it feels like PM.
Oh, yeah, you have to be very careful, yep. But they're in the same AM. Okay, so at 11 a.m., how many miles did it read? 45,000. Minus, what was my starting? And then you just do the math. Subtract it and divide it by 6. And that would be your average rate of change.
So how is this different?
It's not.
How is it different from
Linear functions have a constant slope. Like if your slope was negative 3, it would be down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. But in a non-linear function, your graph shape changes. .480 divided by 6, that's 80. Now, you need to make sure you include units. What was on top, guys?
kilometers?
So I'm going to put 80 kilometers over hours per hour. Make sure you put your... Let's look at number 2. It says a protein disintegrates into amino acids according to the formula M equals 28 over T plus 2, where M is the mass of the protein measured in grams and T is the time in hours. Find the average rate from 0 to 2 hours. So right there, 0 to 2, is that your X or Y's? X. Okay. So I know that these are my X, so I know that the formula will be 2 minus 0 on bottom. But I need to put what f of 2 is above it, don't I? But do you know what f of 2 is? Can you find it, though? Using the what? formula, because isn't t the hour? So I'm going to go here and find f of 2. 28 over 2 plus 2. And that equals 7. I'm going to make sure you understand how I'm setting this formula up here. Okay, so...
Did you get the 2? Wait, 2 plus t, is that what I said?
Yes, buddy. 2 plus t. T plus 2 on your paper, this formula. Let's just hold on for just a minute. Average rate of change is your x sub 2 minus x sub 1. I determine that the time is my x because it's independent. So I have 2 minus 0. You go above the 2 and find f of 2. Well, I use this formula to find f of 2. 2 plus 2 is 4. 28 divided by 4 is 7. I'm going to input that 7 right above the 2. Are we good so far?
Oh, so the t stands for time.
Yes, because it said t is the time in hours. Yes. But do y'all see how we set this problem up? You see how it's the same formula for slope, but you got to find the y values? They're not giving it to you? Are y'all sure on that? Okay. So the average rate of change would be 7 minus. Now I need to find f of 0. Well, 28 divided by 2 is what? 14. So I get a negative 7 over 2. Mr. Hester, that looks weird. But isn't the protein disintegrating? Shouldn't it be a negative? If it was getting bigger, it'd be positive, wouldn't it? So my negative does make sense. The protein is disintegrating. So on top, M is the mass of protein measured in grams. So it's grams per hour. Because this M tells you the mass of the protein, so I put grams over hour. You will have to put a unit if it's a word problem, or I'm going to count a point off. Yeah, I got 28 divided by 2 equals 14. Because I put 0 in, because f of 0, 0 is your input, 0 plus 2. Mm-hmm. Alright. Yes. Alright, number 3 is just a normal problem. No word problem. It just says, here's a polynomial function. What type of polynomial is that? Cubic. X to the third. And I want to find the average rate of change from when x goes from 1 to 3. So these are my what coordinates? These are my what coordinates? X. So let's set this up. AROC equals, which is x sub 2? 3 minus 1. So above it would be f of 3 minus f of 1.
Is it always on the list, the x's in order?
Yes. Whichever one x comes first is your x sub 1. Second one's x sub 2. Do you know the value of f of 3 by just looking at it right now? So do you need to work that out? Yes. So I'm going to do f of 3 equals 3 cubed plus 2 times 3. What's 3 cubed? You should know that by heart. 27 plus 6 equals what? 33. I'm going to put that right above 3. Minus f of 1. Plug that in. 1 cubed is 1 plus 2. That equals 3. Did y'all get 3? I do need to see it set up like this. I need you to see your initial setup like this before you start working it, okay? Because I want to make sure you understand that. What's 33 minus 3? 3 minus 1 is? So what is your answer? 15. So you said, Mr. do I have to put units on this? No, because I didn't give you units. But if it's a word problem, you need units. I'm not going to do both of these because it's the same thing. We're just doing A on that one. But the average, do you understand why we have to do AROC for the other function besides linear? because they're not the same shape. They're doing different things. They're increasing, decreasing at different times. So you just have to isolate an interval and find it for that specific interval. That's why AROC comes into play. We're going to skip number 4 and we're going to go to number 5. Oh, no, you're fine, buddy. It's 15.
You got 15.
Yeah. Yeah, I got 15 right there. I boxed it in. Let's skip number 4 and we're going to go to number 5. This is a polynomial, isn't it? What specific type of polynomial? Quadratic. Very good. Remember, things go into the squares, cubes, fourths, fifths. They all belong to this big family called polynomial. They just have specific names. So if I graph this quadratic, something in the shape of a what? Parabola. I want to know what's going on between 1 and what? 3. 1 and 3. So, what is my... Okay, so AROC equals... So, what is my x sub 2 value? 3. What's my a sub 1? I mean, my x sub 1. 1. X sub 2 is 3. X sub 1 is 1. Now, what would be above 3? F of what? 3 minus F of 1. So, I need to go find what is F of 3. I plug it into this function. 3 squared plus 6 times 3 plus 10. Yep. Plug F of 1 in. Did y'all get 17? So I get 20 over 2, which is equal to what? 10. So your average rate of change for that interval, just for that interval, is the slope of 10 in that particular part of the graph. Okay, I want you to take a moment and give me a handset on what you feel so far. Okay, when I say hand settle, I need something to your chest or I'm going to call you out. Okay. Alright, let's look at the back. Number 6 says, look at the table to the right. What is the average rate of change between the interval of negative 1 and 3? So let's just look at that first. Okay? So let's set up the problem. AROC equals. What is my x sub 2? 3. What's my x sub 1? Okay. So I got 3 minus a negative 1. What would be above the 3? F of what? 3 minus f of what? Negative 1. Okay. Now, I didn't give you an equation, but couldn't you use this chart to find what f of 3 is? Isn't 3 your x value? So what's your y value? So you will plug negative 27 there. Minus, what is your negative? X is negative 1. What's your y value? See, I like these better. You don't have to do all the work. Double negative, double negative. Negative 27 plus 11 is negative 16 over 4, which would be a negative 4. So your average rate of change for that particular problem is negative 4.
You want to do B too?
Yes, we're going to do B on this one. AROC equals, what's x sub 2? 3 minus, what's x sub 1? Negative 2. Alright, what do I come above 3 and put? F of what? F of 3 minus f of negative 2. I'm going to use my table to help me. What is f of 3? Negative 27 minus, what's f of negative 2? I get negative 5 over 5, which is what? Negative 1. The slope is negative, so in that interval right there, the graph is what? Decrease. If it was positive, it would be what? Okay, we're not going to try to finish this. I'm going to stop right there. Let's talk about something here. No, we got a lot more to do on this page. So tomorrow we have to cover this and do start half the lesson. All right. So remember, these things are the same thing, but instead of them giving you your y value, you've got to plug it in to find this value and this value. Do you see that? So your homework's going to be cut down drastically. I just want you to do page 41, numbers 1 through 4. You have 4 problems. Don't come in here without 4 problems, Mark. Do the set. Don't worry about the homework sheet 1 through 9. You're just doing 1 through 4 on page 41. Everybody good with that? Okay. And turn to that and start on the first one now. You got 3 minutes. No, just do page 41, 1 through 4. So guys, if you can't remember this formula, you basically use this formula, can't you? You just got to know that you got to find the y value. Okay?